Hi, everybody. Let's do IXL 7th grade DD.5. Hit Learning, go down to 7th grade, and then down to DD.5. Make predictions using experimental probability. Okay, before we do that, as always, let's check out the reference pages. Here are the reference pages, and probability is on page 11. So I will scroll down to page 11 here. It says over here, page 11. And we already talked about what a probability is if you watched the last video. So when we talk about probability, we're talking about how likely something is to happen. So if there's a 0% chance of something happening, that means it cannot happen. If there's a 100% chance of something happening, that means it definitely will happen. And we can have probabilities in between also. To find what the probability is, then we need to do good over total. So we need to ask ourselves, how many possibilities are good, and compare that to the total number of possibilities that there are. That'll give us the probability that of something good happening. Now, if we know the probability of an event, so we know how likely it is to happen, how can we make predictions? So if I know, let's say, that there's a 70% chance of something happening, and then I do that thing over and over and over again, how many times am I likely to be successful? All of this is going to make a little bit more sense as we do the problems, obviously, but I still just want to read through just this part of the reference page. To make a prediction, we're going to multiply the probability of the event. So that means the first thing that we need to do is actually find the probability of the event. And then once we have that probability, we take that probability and we multiply it with the number of attempts. And this also works for compound events, which we haven't talked about yet. But anyway, it's very simple. We take the probability and we multiply it by the number of attempts. And there's an alternate strategy. We can set up a proportion with the probability on one side. So we have good over total on one side. And on the other side of our proportion, we will have x, which is what we're looking for, how many times we expect to be successful, over the number of attempts, the number of times we're going to try it, or the number of trucks that pass by, or the number of people who walk into a store, whatever it is that we're talking about. Again, if you don't understand that yet, that's okay. As we go through the problems, it'll make a lot more sense. And as always, let me just check to make sure that I'm still recording, so I'm not just talking to myself. I am. Good. So back to IXL. Here's the first question. City Donuts recently sold 15 donuts, of which 3 were chocolate frosted donuts. Those sound good. Considering this data, how many of the next 5 donuts sold would you expect to be chocolate frosted donuts? So again, the first thing that we're going to do is find the probability of somebody buying a chocolate frosted donut. So remember, out of the 15 donuts that were sold at this donut store, 3 of them were chocolate frosted donuts. So that means that the probability that a customer walks in and buys a chocolate frosted donut is going to be 3 out of 15, which is equal to, if we divide the numerator and denominators, by 3, that's equal to 1 over 5. And if we do 1 divided by 5, that's 0.2, which is also equal to 20%. So this is just a lot of ways of writing the probability. But that's not really what the question is asking for. We don't just want to know the probability of somebody walking in and buying a chocolate frosted donut. We want to know if 5 people walk into the store and buy donuts, how many of those 5 donuts sold do we think are going to be a chocolate frosted donut? Because we know that not everybody buys a chocolate frosted donut. So how are we going to figure this out? Well, it's actually very simple. We're just going to take the probability, which was really, we could use any one of these representations. They all have the same value. We just take the probability. I'll just do the original one and multiply it by the number of attempts. So the number of attempts here means the number of donuts that were sold. There were 5 donuts sold. So if we have a probability of 3 out of 15, or 20% of selling a chocolate frosted donut, and we sell 5 donuts, how many of those 5 do we expect to be chocolate frosted donuts? Well, we're just going to multiply these things. I'm going to put the 5 over 1. So now I have 3 times 5 is 15. And 15 times 1 is also 15. And 15 divided by 15 is 1. What does this 1 mean? It means, again, if we sell 5 donuts, we can expect one of those donuts to be a chocolate frosted donut. So somebody probably bought a chocolate frosted donut from us. Now, before I put that into IXL, I'll show you an alternate way that we could have done this. We could have taken, well, actually, before we do that, again, it does not matter which probability we use. I could have used this probability 1 over 5 times 5 would also give me 1. And also, if we do 0.2, I'll do that over here. If we do 0.2 times 5, and 5 times 0, 0 plus 1 is 1. And then we have 1 space here, so 1 space over here also. Again, I get 1.0, or just 1. So no matter which value I use here, as long as I take that probability and multiply it by the number of attempts, then that I get my prediction. So I predict that out of the next 5 donuts, one of them will be a chocolate frosted donut. Now there is another way that I could have done that. I could have also set up this proportion, this proportion over here. And so I take the probability on the left side. Well, it doesn't matter what side. It could be left or right. So the probability that we found was 3 out of 15. And on the other side of our equation, we'll write x. So that's going to be our prediction out of the 5 over here. Okay, and then we can just cross multiply here. So we have 15 times x is 15x equals 3 times 5 is 15. And then to get the 15 away from the x, we will divide by 15. And then we have to do the same thing on the other side. And you can see that we get x equals 1. So again, there are multiple ways of doing this. 1. Okay, next question. Mai has eaten 16 donuts over the past few months. Of those donuts, 8 were jelly-filled donuts. Considering the data, how many of the next 6 donuts Mai eats would you expect to be jelly-filled donuts? Okay, So this one is like the last one. I'll just go through it quickly. The probability is 8 out of 16, which is 0.5 or 50%. So 50% of the donut. Wow, there are a lot of people eating donuts in these questions. Okay, so 50% of the donuts that Mai eats are jelly donuts. Oh, I like jelly donuts. Good going, Mai. So if Mai eats another 6 donuts, how many of those donuts would we expect to be jelly-filled donuts? So if we're watching Mai eat a bunch of donuts, I don't know why we would want to do that, but we will. If we watch Mai eat 6 donuts, how many donuts out of those 6 would we expect to be jelly donuts? Well, 50% of the donuts that she eats are jelly donuts. If we just do here 0.5 times 6, then we'll get 3, right? So 3.0 or just 3, which makes sense because 50% means half, and 3 is half of 6. Okay, so when she eats 16 donuts, 8 of them are filled with jelly. If she just ate 6 donuts, we would expect 3 of them to be jelly donuts. And again, we could also set up a proportion. 8 over 16 equals x over 6. And we can do 8 times 6 is 48 equals 16 times x. Divide both sides by 16. That cancels. And then 48 divided by 16 is 3. You could use a calculator for that if you want. But that's our prediction. 3 jelly-filled donuts. Okay, so this is the same type of question. I'm going to move on to hopefully a different type of question here, which I get to do as the teacher. You actually have to get a bunch of questions right to move to the next level. Yesterday, a car rental agency rented 2 minivans and 4 other vehicles. Considering this data, how many of the first 3 vehicles rented today should you expect to be minivans? This question looks a whole lot like the previous 2 questions. So how is this question different from the other ones? Well, it's very subtle. You need to notice here that, let me read the sentence again slowly. Yesterday, a car rental agency rented 2 minivans and 4 other vehicles. So that's where you have to look carefully. The 2 minivans are not included in the 4 other vehicles. So we have 2 minivans and then 4 completely different types of vehicles, maybe cars or trucks or motorcycles. Okay, so that's important. That means when we find the probability and we do good over total, well, what do we like here? What are we considering good? How many would we expect to be minivans? So the minivans are good. So we have 2 minivans. That part is the same as the last couple of questions, but then finding the total is going to be different because again, this 4 here does not already include the 2. So how many total how many total vehicles were sold yesterday? It would be the 2 minivans plus the 4 other vehicles, which means 6 vehicles. Okay, so the probability of somebody walking into the car rental agency and renting a minivan is 2 out of 6, which is 0.3 repeating, or approximately 33%. So about 33% of the vehicles rented are minivans. So the next day, which is today, if 3 people rent vehicles, how many out of those 3 vehicles would we expect to be minivans? Well, we'll just take our probability 2/6 and multiply it by 3, and we can put the 3 over 1, and we'll get here 2 times 3 is 6, and 6 times 1 is 6. And okay, so I'm getting another question here where I have to do 6 divided by 6, and I'll get 1 as the answer. And we could also set up our proportion 2 over 6 equals, it would be x over 3, and then cross multiply, we have 6 equals 6 times x is 6x, then divide both sides by 6 to get rid of this 6, and we get x equals 1. So again, we could also use the proportion strategy. It will give us the same answer. So we expect 1 out of the 3 to be a minivan. Let's see. Yeah, so you really have to be careful when you're doing these problems. You have to decide if you should be adding the numbers in the denominator. So let's read this question. The Sweet Slice Cafe recently served 6 pastries, including 3 bran muffins. So let me pause there. A bran muffin is a kind of pastry. Are these 3 bran muffins already included in these 6 pastries? Yes, they are. It says it right here. Including 3 bran muffins. So that means before I even do anything else, the probability that somebody buys a bran muffin is going to be 3 over 6. I am not going to add the 3 and the 6 together because this 6 already has this 3 in it. So it must have been 3 bran muffins and then 3 other pastries, whatever they were, to make these 6 pastries. But anyway, these 3 bran muffins are already in here. They are already in the total. Considering this data, how many of the next 8 pastries served should you expect to be bran muffins? Well, 3 out of 6 equals 0.5. If you don't believe me, just go to a calculator and do 3 divided by 6, or do the long division, which is equal to 50%. I know that 50% of people, meaning half of the people, are buying bran muffins, or at least half of the pastries sold are bran muffins. So if we sell 8 more pastries, out of those 8, we would expect half of them to be bran muffins, and half of 8 is 4. Again, we can go ahead and do 0.5 times 8, which is 4.0, or 4, okay? If you want to do 3/6 times 8, you get the same answer. 24 divided by 6 is 4. We get the same answer here and here. We could also do the proportion strategy. 3 over 6 equals x. That's going to be our prediction. How many pastries do we predict will be bran muffins? Over 8. Okay, we get 24 equals 6 times x is 6x. Divide both sides by 6, x is equal to 4. Okay, same answer no matter what I do. There we go. Let's see. Is the next kind of question the same kind? Yeah, so it's the same kind of question. And again, the important thing to try to figure out is, should you be adding the numbers in the denominator? So I'll just read through this. I'm not going to do all of the math about it, but let's just read through it. Kimmy surveyed 12 students at her school about their favorite colors. Of the students surveyed, 3 said red was their favorite color. So again, let me pause here. Is this 3 included in this 12? It is included. How do I know that? Because it says here, of the students surveyed, 3 said red was their favorite color. So these 3 were already included in the students surveyed. That means that when you do good over total for this question, you would not add up these numbers because the 3 is already in here. These 3 students who said red was their favorite color were already included in these 12 students who were surveyed. So we would not add the 3 and the 12 for this. And the rest of it would be exactly the same as the last few questions that I've done, so I'm not going to do the math again for this one. Let's move on to the next section and see if we get different types of questions here. Of the donuts recently sold at Daily Donuts, 38 had sprinkles and 10 did not. Considering this data, how many of the next 72 donuts sold would you expect to have sprinkles? Yeah, again, it's the same kind of question. You have to decide, should you be adding these numbers here? Okay, I'll let you read that. What do you think? Oh, actually, this is a different kind. You know what? My mistake. This is sort of a different kind of question here. So I will go through this. So 38 had sprinkles and 10 did not. Considering this data, how many of the next 72 donuts sold would you expect to have sprinkles? Oh, no, it's not a different kind of question. Okay, so this would be, yeah, really, it's the same kind of question. The good kind of donuts are donuts that have sprinkles. That's not because I like donuts with sprinkles. It's because the question asks us to predict how many donuts would have sprinkles. So that means we need to look at this number here, which is the number of donuts that had sprinkles, and that's going to be what we put here in the numerator. And the denominator, should we add these two numbers up? Yes, we should. How do we know that? It's because this 10 is not included in this 38. These are 10 different kinds of donuts. These 10 donuts are donuts that do not have sprinkles. So Daily Donuts, the donut store, sold 38 donuts that had sprinkles and 10 donuts that did not have sprinkles. So what's the total number of donuts that they sold? It would be 38 plus 10, which is equal to 48. Okay? And let's just go ahead. I'll just finish the problem up. 38. Let's use the proportion strategy here. This is going to be 72. All right. I probably could have reduced this fraction beforehand. That's okay. If you have a calculator nearby, it's really not too hard. Just do 38 times 72, 2,736 equals 48x. That's from here. Divide both sides by 48. So the reasoning behind using the proportion is that we expect the ratio to stay the same whether the donuts were sold yesterday or today. So if 38 out of 48 donuts had sprinkles, then how many donuts out of 72 would have sprinkles? So we'll just take this number now and divide it by 48, and we'll get 57. Okay. Let's move on. Yeah, let's move on. I think the rest of the questions are really about the same. On a game board spinner, Avery won a prize on 8 spins and failed to win a prize on 4 other spins. Based on experimental probability, on how experimental probability means we're determining the probability based on our observations. So we observe Avery winning a prize 8 times and not winning a prize 4 other times. On how many of the next 84 spins should Avery expect to win a prize? Yeah, it's the same kind of a problem here. For this type of, we would add up 8 and 4 in the denominator for that one, because this 4 is not included in the 8. Okay, but I'm not going to go through the whole thing. It's exactly like the questions that we've done already. Okay, so have a great night.